Hello everyone, welcome to the SR Math Learning channel. So in this channel, we are discussing everything conceptually. So concept and related problems. So like that we are explaining in these videos. So kindly subscribe to my channel and please enjoy the concept oriented learning. So in the part one, we discussed what is the definition of the function and different types of functions we saw, and basic problems, how to find the domain, that all we saw in the part one. And the algebraic functions also we discussed. So in this part two, we are going to discuss transcendental functions. So in this part, we are going to discuss transcendental functions. So under this transcendental functions, we will get the different types of functions like exponential function, logarithmic function, trigonometric functions like this, inverse trigonometric functions like this we'll get. So majorly in this, we are going to discuss exponential functions and the logarithmic functions. So if possible, we will discuss the trigonometric functions also based on the time. So first, let's see what is exponential functions. What is exponential functions? So let's see what is meant by exponential function and its graphical representation. The function f of x is equal to a power x. The function f of x is equal to a power x, where a greater than 0 and a not equal to 1 is said to be an exponential function. So here a is constant. So here this always we will discuss in two different cases. If a lies between 0 and 1, and another one is if a is greater than 1, means when basis lies between 0 and 1, and when base is greater than 1. So when basis lies between 0 and 1, so what is the graph of this function is? It is a decreasing function. So we're like xo, x dash, yo, y dash. So the graph for when base is lies between 0 and 1, f of x is equal to a power x. Graph will be so like this, but it never becomes 0. So it cuts the y-axis at 1, 0. So this is a decreasing function when the base is 0 to 1. So when the base is greater than 1, so the graph of f of x is equal to a power x is an increasing function. So it will increase like this. So it is an increasing function. So even it is cuts at 0, 1 only. So this is 0, 1 point on y-axis. So at 0.1, it will cut the y-axis. So this is the predefined domain. These things will have predefined domain, and the predefined ranges will be there. So what is the domain of f of x is equal to a power x is? So for all the real numbers, this will be true. So all the real numbers, it will be true. So range will be only open interval 0 to infinity. So even we will not get 0 also. So and a power x value is always lies between 0 to infinity. So for example, if I substitute x is 0, so see here, this value is 1. If I'll substitute x is equal to 1, so this value is a. If I'll substitute -2 also, 1 by a square, it will become but it never equal to 0 or negative values. So domain and range of f of x is equal to a power x will be r and 0 to infinity open interval. So this is the exponential function. So let's see the logarithmic function. Let's see the logarithmic function. So if you look at the logarithmic function, so f of x is equal to logarithmic function. So f of x is equal to log x to the base a, where a greater than 0 and x also greater than 0, and particularly a not equal to 1 base. We will talk particularly about the base only in the exponential functions. Here also same way, two conditions we will discuss: when the base is lies between 0 and 1, and when base is greater than 1. So when base is lies between 0 and 1, so it is a decreasing function. So it is a decreasing function. So like this the graph will be. So graph of this one will be, so graph of this one is like it's a start like this and it decreases continuously. So like this. So here there is a chance of getting the negative values also. So for different values of x, so it curves the x-axis at 1 comma 0. It curves the x-axis at 1 comma 0. So this is the graph of log x to the base a when base is lies between 0 and 1. So second thing, the graph of f of x is equal to log x to the base a when base is greater than 1. When base is greater than 1. So when base is greater than 1, it is an increasing function. So it will come like this. So even this also, so it curves the x-axis at 1 comma 0 only. So this is origin, this is x and x dash, y and y dash. So here, what is the domain? What is the domain? Domain means what values x accepts here. So f of x is equal to log x base a. Very clearly, x is greater than 0 here. For negative values or for 0 also, we cannot define the logarithmic values. So clearly, what values it will accept is from open interval 0 to infinity. So range, what is the range of this log x is any value of r. So all the real numbers will get as the output values. So it's just ulta of a power x, just reverse of a power x. So these are the two functions, transcendental functions. So let's see the problems based on these two. Then we will go to the next topic. So what is the question? First question here. So let's see how to solve the question. Find the domain of the function. Find the domain of a single valued function. A single valued function. Single valued function. Y is equal to f of x given by the equation 10 power x plus 10 power y is equal to 10. So let's see how can we take the domain of this one. So let's see the solution. So it's very simple. What they're given is 10 power x plus 10 power y is equal to 10. So from here we'll get 10 power y is equal to 10 minus 10 power x. So when I'll change this into logarithmic form, y is equal to 10 minus 10 power x to the base 10. So here very clearly we know that this should be greater than 0 always. So that should be greater than 0. That means 10 minus 10 power x should be greater than 0. So from here what we'll get is 10 is greater than 10 power x. So that means 1 is greater than x. So which one will get x is less than 1. So x is less than 1. So therefore domain of the given function is minus infinity to 1. So open interval. So because they told x is less than 1. So this is the way how we will find the domain of this one. So let's just see one more question. Question number 2. Find the domain of find the domain of f of x is equal to 1 by root over log x square minus 7x plus 13 to the base 1 by 2. So when f of x is exist here, that first we have to check, then we have to simplify it and we have to find out the domain. So f of x exists here, f of x exists if log x square minus 7x plus 13 to the base 1 by 2 is greater than 0. So base 1 by 2 is greater than 0. So if you look at here, when we are discussing the logarithms topic, I told very clearly that when you are solving the logarithmic inequalities, you have to check the base first. So if basis lies between 0 and 1, so when you are changing to exponential form, this inequality changes. So here it is changes as x square minus 7x plus 13 is lesser than 1 by 2 whole power 0. 1 by 2 whole power 0. So that is x square minus 7x plus 13 less than 1. So you will get x square minus 7x plus 13 minus 1 is less than 0. So from here we will get x square minus 7x plus 13 is less plus 12 is less than 0. So let it be 1. Let it be 1. And very clearly we know that in this logarithm, here in this logarithm, again we can get like x square minus 7x plus 13 should be greater than 0 compulsory. Should be greater than 0 compulsory. So let it be 2. So this from here, how can we write this one is x square, I will multiply and divide with 2 here. So then it will become x into 7 by 2. So plus 49 by 4 minus 49 by 4 plus 13 is greater than 0. So this can be written as x minus 7 by 2 whole square plus 3 by 4 is greater than 0. So this is true because this is true for all the remaining, because here we have the square for this bracket. So whatever the value you will substitute, you will get positive only, and this plus 3 by 4 here. So whole value will be greater than 0. So for all x belongs to real number, this is true. So from here we got this one. So from the equation 1, what we are getting here, so 12 means we can write x square minus 4x minus 3x plus 12 less than 0. So this is we'll get x into x minus 4 minus 3 into x minus 4 less than 0. So where x minus 4 into x minus 3 less than 0. So that is x is lies between 3 and 4. X is lies between 3 and 4. So from here, from this result and this result. So what is the common domain? What is the common domain is? So domain of this function is open interval 3 to 4. So open interval 3 to 4 is the common domain for total f of x is equal to 1 by root over log x square minus 7x plus 13 to the base 1 by 2. So this is the solution for this question. So next. I have some different questions here based on the logarithm. So let's see that questions. So in that first question means the third question here. Find the domain, very small problems for conceptual clarity. Find the domain of a function. Find the domain of function f of x is equal to 1 by log 1 minus x to the base 10 plus root over x plus 2. So how to solve this question? Important thing is here we have one logarithmic function, one square root function. So one logarithmic function, one square root function, and that logarithm of 1 minus x to the base 10 is in the denominator. So case 1. So how can we solve this? 1 minus x not equal to 1 first of all, because if it is equal to 1, log 1 to the base 10 is 0. So 1 by 0 will be infinity. So that by not equal to 1. That means x not equal to 0. And very clearly, then 1 minus this 1 minus x should be greater than 0. From here, we'll tell that x minus 1 is less than 0 and x is lesser than the 1. So this is one solution. Case 2. So case 2, in case 2, this we will take square root. So in the square root, the square root is in the numerator. So x plus 2 is greater than or equal to 0. So from here, x is greater than or equal to minus 2. X is greater than or equal to minus 2. So if you'll see the values, what we got is here minus 2, let's we take 0 and 1, because here we got the x is less than 1. Here we got x is greater than or equal to minus 2. And here we have one more condition is x should not be 0. So how we will take the common domain is x is greater than or equal to minus 2, means x is greater than or equal to minus 2. So here it is closed, means minus 2 also can include. And x not equal to 0 they are given. X is less than 1, where it is open circle because 1 should not be included. So if you look at clearly, in between minus 2 and 1, actually this is a common area what we can take the values for x. But in that, since at 0 it is not defined, so we can write the domain of this function is domain of f of x here. We can take like closed interval minus 2 to 0, closed interval minus 2 to 0, union open interval, I mean minus 2 to 0 open, and union 0 to 1 open interval. So this is the way how we will find out the domain and how we will finalize it. So next one more question. So question number 4. So find the domain of f of x is equal to log 1 plus x cube to the base 10. So how can we find the domain of this one? So if you'll see very clearly, here we have x cube 1 plus x cube. So solution for this one is, so 1 plus x cube should be greater than 0, and at the same time x not equal to minus 1. X not equal to minus 1. Why x not equal to minus 1 now? When I'll substitute x minus 1 here, it will become log of 1 minus 1 because it is cubing to the base 10, which is log 0. Log 0 value is not defined. So that's why x not equal to minus 1. And at the same time, 1 plus x should be greater than 0. So from here, how can I write? Just ulta palta, x cube plus 1 is greater than 0, we can write. From here, we will get x cube is greater than minus 1, means x is greater than cube root of minus 1. That means we can write that x is greater than minus 1. So x not equal to minus 1, x greater than minus 1. So it's not a problem because anyhow, this is greater than only. So therefore, domain of this f of x is, here open minus 1 to infinity, because it is greater than minus 1. So let's discuss one more problem based on these logarithms. So question number 5. So question number 5 is, I will add one more log to this. Find the domain of f of x is equal to log of 10 base 10 to the log base 10 to the 1 plus x cube. So for the previous question, I added one more logarithm here. So how to solve this question? So let's see. So first, this should be greater than 0. First thing is this should be greater than 0. So case 1 is here. Log of 1 plus x cube to the base 10 is greater than 0. So just now we saw for this we got the domain as minus 1 to infinity open interval. Right? Okay. Sorry. This, okay. We are taking fully right. So let's just say not this one. So then if we change it to exponential form, we'll get 1 plus x cube is greater than 10 power 0. That is 1 plus x cube is greater than 1. So where x cube is greater than 0. So x greater than 0. This is one answer. And again, when I will take this particular function log of 1 plus x cube to the base 10. Here 1 plus x cube should be greater than 0, which is x not equal to minus 1. So for this, we got the domain is minus 1 to infinity. So here x is greater than 0 means here domain is 0 to infinity. So which is the common domain it will satisfy is 0 to infinity, because minus 1 to 0 it may not satisfy. So that's why common domain here. Common domain is open interval 0 to infinity. Common domain is open interval 0 to infinity. So this is the way. So how we will solve the problems on logarithm, how to find the domain of logarithmic functions. Based on the logarithmic functions, how to find the domain, I gave you here 5 homework questions. So please try to solve based on this concept, these questions. So please note these questions and solve these questions. Solutions will be discussed in the next video. So this is about the domain of logarithmic functions, exponential functions under the transcendental functions. So let's see next type of transcendental functions, that is the trigonometric functions. So for the trigonometric functions, let's discuss what is the domain, what is the range. So here now we are going to discuss trigonometric functions. So let's see. So first f of x is equal to sin x. So what is the domain and the range of f of x is equal to sin x? So in the trigonometry, in my previous videos, I discussed this very clearly. So how we will get the graph of sin x, and once again I'm discussing here. Those who are not seen that trigonometry, please you can observe here. So when I will for complete information like with numbers, everything, so you can look at my trigonometric videos. So here just I'll explain how we will get the graph of this one. So when I'll substitute x is equal to 0 here, we will get 0, and when I'll get x is equal to pi by 2, if I'll take sin x value is 1, when it is pi, it is 0, when it is 3 pi by 2, when it is 3 pi by 2, it is minus 1 we will get. It is 2 pi, it will be 0 again. Like that, this side also, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. So for minus pi by 2, we will get minus 1. And for pi, all the multiples, integral multiples of pi, it will be 0. And for minus 3 by 2, it is 1. So again 0. So if you'll draw a free-handed curve here, so you will get the graph of f of x is equal to sin x will be like this. So this is the graph. So here sin x is defined for all the real numbers. So for all real numbers, sin x is defined. But if you observe the range clearly, range maximum you are getting 1 and minimum you are getting minus 1. So range of sin x is minus 1 to 1. So that means the sin x is always lies between 1 and minus 1, including minus 1 and 1. So this is the domain and range of the log, f of x is equal to sin x. So next, let's see f of x is equal to cos x. F of x is equal to cos x. So what you will get f of x is equal to cos x. So if you see, this is y-axis, this is x-axis. So very clearly at 0, cos x is 1. Cos x is 1. At 90, it is 0. At 180, it is minus 1. It is minus 1. At 3 pi by 2, it is 0. So for 2 pi, again it will be plus 1. So like this. So for minus pi by 2, it will be 0. For minus pi, it will be minus 1 you will get. So this side, if I'll go for this one, 0. 0, minus 3 pi by 2, minus 2 pi, it is plus 1. So x4 x dash, y4 y dash. So if I'll draw the graph here, the graph of cos x will be, it will be like this. This is the graph of cos x. So here also, maximum minimum will be minus 1 comma 1 only. So range of cos x will be minus 1 to 1, and the domain is for all the real numbers it is true. For all real numbers it is true. So if you look at the tan x graph, so y is the f of x is equal to, or y is equal to tan x. So how will be the graph of f of x is equal to tan x? So let's see. This is my y-axis, and this is x-axis. So here x o x dash, y o y dash. Here we will take pi by 2, and here it is pi, and here it is 3 pi by 2. So minus pi by 2, minus pi by 2, minus pi, minus 3 pi by 2. So if I'll draw the lines at these intervals parallel to y-axis, so like this, through the pi by 2, through the pi is actually not required. Pi is actually not required. So we'll draw the line at odd multiples of pi by 2. So like this, not at pi, not at pi. So it is at pi by 2. And again at minus 3 pi by 2. Yes. So tan is increasing above the x-axis and decreasing in below the x-axis. But at pi by 2 it is infinity. So it never meets the dotted line. It will go like this. It will go like this. It's never meet pi by 2. So, and pi by 2 to 3 pi by 2, it will be like this. At pi by 2 to 3 pi by 2. And in minus 3 pi by 2 to minus pi by 2 also. So it's not touching actually. Just it will go like this. So this is the graph of f of x is equal to tan x. So for what values here? For what values tan x is not defined is, it is true for all the real numbers except odd multiples of pi by 2, except where n belongs to z. So range though you get all the real numbers. So range you get all the real numbers, but domain for every odd multiple of 90, it will not define. It will not define. So this is the graph of tan x. Next, graph of cot x means f of x is equal to cot x. So just it is ulta for the graph of tan x. So this is, let's think, y-axis and the x-axis. So x o x dash. So y o y dash. So here the points to be marked at pi by 2, cot is 0, and at 3 pi by 2 again it is 0. So between this pi by 2 and 3 pi by 2 we can draw one line like this. So again here one more line, here one more line we will draw, and here also this side it will be 0 at minus pi by 2, minus pi by 2 comma 0, and at minus 3 pi by 2 comma 0, at minus 3 pi by 2 comma 0. So it will be like this. So when you will draw the graph for this one, it will come this like this. So at this point, minus pi by 2. So it will come like this. So this point. So what is the domain of this one? So domain where it will not be defined is for all the real numbers except multiples of pi, except multiples of pi. So that is n pi. So range is r only. Range is r only. So comes to the f of x is equal to cosecant x and secant x graphs. So f of x is equal to cosecant x first. So let's draw the graph for this one. So let's see for this one, y-axis and x-axis. So pi by 2, pi. So at pi we will draw one line parallel to y-axis. So again at 3 pi by 2 and at 2 pi we can draw a line. So if you'll see this side again, so if you'll see this side, left side, x dash side, so in this direction. So at minus pi, so pi by 2, at minus pi, we'll draw one dotted line. And 3 minus 3 pi by 2 is again named, and minus 2 pi is here. So we can draw like this. Draw like this. So very clearly, the graph is defined above the some level. So like this in U shape. So here this point is minimum point where you will get minimum value for cosecant x. That is at pi by 2, you will get the minimum one. So in this interval, pi to 2 pi, you will get maximum. So that maximum value will be so like this. Maximum is this point is at 3 pi by 2, comma, minus 1. So for the left side of this y, so again this is the negative side. Maximum is minus pi by 2 to minus 1. So let's draw clearly. So this is the graph here. This point is minus pi by 2 comma minus 1. So here between minus 2 and pi, it will be above the x-axis. It will be like this. So it will be like this. Here minus 3 pi by 2 comma 1, you will get this minimum point. So this is the graph of f of x is equal to cosecant x. So here domain of this function is all the real numbers except multiples of pi where n belongs to z. And range of this function is all the real numbers except minus 1 comma y, except minus 1 comma 1. So let's see secant x. Let's see secant x graph. So secant x graph, let's see. So here we are going to discuss f of x is equal to secant x graph. So let's see how we can draw the graph here. So at pi by 2, at 3 pi by 2, we will draw the parallel lines to the y-axis. So like this, because cos pi by 2 is 0, secant pi by 2 is not defined. So wherever it is not defining, so we are drawing the lines, dotted lines, which is parallel to y-axis. So at minus pi by 2 also, secant x is not defined, and at minus 3 pi by 2 also, it is not defined. So you will see clearly this minimum exists here for the secant x is for the 0 comma 1, maximum exists here is like this minus 0 comma minus 1. So the graph for this one will be here like this. After 3 pi by 2, it is positive like this you will get. So this is the where 2 pi comma 1. And here between pi by 2 and 3 pi by 2, so it is negative side. Maximum exists at this point. So that is at pi. So we'll take this one minus 1. So here again, this is about the y-axis, symmetric about the y-axis. It will be like this at 0 comma 1. And again, in this place is like this graph. And again, it is like this side. So like this. So this is the graph of secant x. Here domain of secant x is r minus all the odd multiples of pi by 2. It is not defined. So where n belongs to z. So range will be the same like cosecant x. For all real numbers we will get except minus 1 comma 1. So these are the graphs and the domain and the range of the trigonometric functions. So this is today's topic in this video. So we'll discuss the inverse trigonometry, transcendental functions, inverse trigonometric functions, and related problems we'll discuss in the next video. So keep watching my channel. So here all the topics and the questions will be discussed conceptually with the full length solutions, no shortcuts. Full length solutions we will discuss conceptually. So this, my intention is to understand each and every learner. So please keep watching my channel for better understanding. Please support my channel and please subscribe to my channel. Thank you.